everybody, to the AWS Summit here in Washington, D.C. I am your host, your neighborhood-friendly senior security solution architect that focuses on threat detection and incident response. Time that one, Aaron. I dare ya. I am Kyle Dickinson once again, and I am joined by a new host. You see that Jeff has been replaced, never replaced, just he's on break.
That's right. Hi, everyone. My name's Navas. I'm a cloud governance specialist. I'm a host once in a while, and here I am again.
Yeah, and don't forget we have our awesome executive producers over there, our awesome ASL interpreters over there, awesome camera crew, and also some awesome friends to talk about decentralizing policy management using AWS organizations. It's almost like a theme of organizations this morning, isn't it?
Well, thank you for having us. My name is Alex Torres. I'm a senior solutions architect on Cloud Foundations, and I work a lot in multi-account and organizations and all of these things. And I'm here with George.
I'm George Ralston here. I work here with Alex at with Cloud Foundations at AWS. I'm a senior solutions architect. And here today, I guess, we're going to go over delegated policies.
Yep.
So what is it when we're talking about decentralizing policy management, and how is this going to help our customers ultimately be more secure and also understand what sort of policies are in place in their organization?
So when we talk about, we've been talking all morning about organizations and multiple accounts, right? And when we talk about splitting the management of not only policies but services, right? Making sure that not everything is in that management account and you can secure things better and making sure that the right teams have access to the right services. Well, in a similar way, we can do the same thing with policies. Like we've been talking about service control policies, tag policies, backup policies, and AI/ML opt-out policies that are the policies that are available on organizations. You can also delegate that to a given account, and that account one or more, so you can have different teams managing their own policies. So,
Sure. And I have a question for both of you. Why should we limit activity within the management account?
So think of this, within the management account, that's the one that really has the control over the organization. It's the one that you really want to quiet the scene, I always say. Everybody's like, well, the quieter it is, the better you can monitor it. It's one of these places that just can reach into all the other accounts in the organization. So you just getting any type of service, any type of management of a service delegated out of the management account is the best way to do that.
Sure. So you want to limit activity within the management account, and it's a very powerful account.
Yes.
So potentially reducing the risk of anybody disabling controls across member accounts.
exactly.
Right? Yeah.
Now, one of the things, so coming from a threat detection and incident response background, we always think about, the crown jewels, and the management account can be considered a crown jewel because it has the ability to create resources within all of the other child accounts. If you think about, configuration management systems, if someone that's unauthorized gets access to that, they can impact a wide scope. And so delegating administration, one is, I think, a very powerful feature.
Yes.
Because it allows us to move, say, for example, like our guard duty administration for our organization to, say, like the security account. And just other things that I'm not going to spoil what you guys have to talk about, because also you touched on tag policies. I think tagging is one of the more underutilized and overlooked things that you can do within AWS from an operational point of view, from an incident response point of view, but also maybe even just like billing point of view too, for like
Yes.
bill back of utilization of services. And so how is it that we could do tag policies in a decentralized way too?
So, and that's what George is going to show us in just a second, but basically what you can delegate the management of certain tag policies or service control policies to a given account, and you can limit what tag policies that account has access to, so you can make sure that a business unit within an organization is only managing the tag policies they're supposed to be tagging and enforcing and making sure that those tags are applied across all those accounts within that business unit. And that way, you wouldn't allow from the management account or access to all the other tag policies that they may not need to have access to.
Sure. Now, given that we're here at the DC Summit and we have a lot of regulated industries that may be utilizing GovCloud, does GovCloud have the ability to do these policies as well?
Yes, we actually released this in GovCloud about 2 months ago, so all this policy delegation is also available in GovCloud right now.
It's almost like a perfect timing question.
Yes.
Awesome.
So, well, let's take a look to see how this actually is deployed out. Again, it's slightly different than you think of the traditional like delegating an actual AWS service there. It's, you know, if you're wanting to do something like guard duties you mentioned, and you're going to delegate that out to one account. But with delegating policies, it's slightly different. I'm going to show you what I mean. In here, you can see I have an account. I have my management account I'm going to go into. And jump in there. And the policy delegation is actually part of AWS organizations. So we're diving into AWS organizations. And we're going to go into the settings of organizations. Now, the first thing that you'll see here is that we have the delegated administrative services here. And how this is delegated, it's no longer just select just one account, maybe one or two. You can have some that have multiple accounts and select. But this is a policy-based delegation, and it's very, very powerful in there. So you can look down and see, you create this actual policy. This policy would say different things. It's very similar to your IAM policies and everything. You're giving actions. The big point I want to point out here is when we're actually delegating out, we're able to say different principles. So not only in this policy I'm showing you right now is saying, hey, this account can do these organization actions that describe different things, but I can also use roles, different things there. So this is a very a tool that you can fine tune and be very prescriptive on what you want to be done in that environment. It's not, hey, just manage this for everything, which you can put that in there if you want. Or you can say, in this one, I'm saying I want this account here to manage a specific OU. I'm giving permissions to a specific OU. I'm not saying everything out there in the organization. I'm saying, hey, you can only do these actions for this OU.
Wow, that's quite powerful. So I guess I'll give you possibly a real life scenario. Imagine if I have a machine learning team that has their own set of organizational units plus their own accounts. We can delegate a policy using organization so that the ML administration team has complete access over their environment and sensitive data sets?
That's exactly. Yes. And one of the things to note is that because of that OU, the way that the policies kind of work down is that I can give them access to that OU, but at the top, I can put another SCP in there where they can't change and mess with it. So you can actually look at and saying my controls are placed at the top level of the OU structure. I'm still this group. They want to do their own management of SCPs. They want to, maybe they're debugging or they have certain things they want to get in place. Yeah. I've enabled them to do that. I want to get out of the, I want to let them, I want to maintain my security by placing that at the top. But then, hey, you can manage your own OU. Attach, detach SCPs.
Even like with like OUs for like sandbox environments where you have a little more leeway and a little more play, and you also want to maybe understand how does a service control policy impact that OU and delegate that to the development team or machine learning team, whoever it may be.
Yeah,
exactly.
Yes. And I was just going to say, like, this is a great example of balancing security governance with the agility of your development teams.
Exactly.
I always call it going from a bouncer to a bodyguard.
I've looked at it saying you just want to get out of the way, let them get their job done. They have a specific job, maybe that OU, that workload that you've designed in there as a specific thing, and maybe they want to start testing. Like the sandbox is a great one, so you can actually go create multiple policies in here, create multiple statements in this policy, and have different management, as you can see. So whatever you can slice and dice within that policy document is what you can create for that. And it's another great feature of this, I just wanted to point out that a lot of times as you're doing this policy delegation, you see that you have the organization's described services. So even accounts, you can go in and say, hey, I just want to be able to list these things, or list accounts. You can actually put that in here so automation can help out and things, and you do not need, again, a big point of this is staying out of the management account. We do not want to be, if we don't need to do our work in the management account, please stay out. Delegate this. You should put this in place at different levels and just really quiet, I always say quiet the scene in the management account. Yeah. Like, why are you logging into the management account? Just only log into the management account when absolutely necessary.
So when a customer is planning to look at delegating access to this and using these type of policies, are there any limitations that they should consider, or at least understand they may be able to running into, so they're able to address them before they...
So some of the best practices we have for creating this right now is one, make sure you understand what you're getting into. I mean, at the bare minimum, we always say delegate out. Delegate this out of there. But as you're starting to design this out, make sure, one, when you design that, when you start looking at the OUs and the accounts that are in that OU, the management account is one of those accounts that's not affected by SCPs. And there's a reason for that. That's because you don't want to shoot yourself in the foot, get locked out. Same process here. If you're an account, a member account that you've delegated to, those are still impacted by SCPs. So you can end up having that shoot yourself in the foot. Like, oh, and then the team's locked out. So make sure when you're doing that OU structure, don't have the account that's managing that OU structure in being the one being impacted. Try to separate that out so that they're not.
You mentioning locking yourself out just made me resonate about a time where I had locked myself out of so many S3 buckets on accident.
Side story, how did you get out of it?
I had to call support.
Sense.
Yeah.
So just to show real quick, in this setup I've got an admin account and I've got the workload account. So if I'm looking at this in the workload account, and if you do go into organizations, this is what they'll end up seeing. So
and this is a child account within the organization.
They're all member accounts, yes.
Yeah.
I can see in here, big error. This is what everybody sees when you have this without delegation. With the delegation, the policy I put in place, now I'm going to go into the admin account, which I've delegated out. I'm going to jump in there real quick. This is just how to know if it's working or not. Quick check for everybody out there. And as you're going through it, you'll see.
Ta-da.
In that member account now, I'm able to go in and actually see. Prior to this, you couldn't. So this delegation, it's a great tool for automation in there. But as you see within policies, I've delegated out this ability. I just want to you can see let's go to the temp policy here. I'm in there. I'm in my member account now that's supposed to be managing policies, so I'm able to save, I'm able to edit policies. I've given the permission to do that. I can also go in, and you can see that right here, it's attached to the workload OU. So we can go in and detach that. It'll say detach. Good, I can actually detach, but then I want to show you here, what if I said I want to attach it to the sandbox? And I go to try to attach. If it lets me click, there we go. And I can't do that. I can only manage from this account the actual workload OU. I can only have that in there. So let's see, click in there, remove this guy here, and do a retry attach, and you can see I've attached.
Sure.
And I think it's worth mentioning that when working with these delegated policies, that implementing IAM best practices is also very important, because if we looked at the policy previously, anyone that logged into this specific AWS account is able to make modifications.
Exactly. You can scope that down to a specific role. And prior to this, it was like if that account's been delegated, that role, any principal in that account that has the IAM permissions can do those things.
Right.
Not with this. If I would have set a specific role, then regardless of my IAM permissions, I have to be in that role to make those actions. So it's being able to tune that down and target exact roles in the account.
And can you have multiple delegated accounts?
Yes.
Yes.
Oh,
so
cool.
you can, like I said, you can slice this and dice this any way you like. But have a plan exactly, and focus on enabling and securing. Look at security going down and make sure that you put those controls in place, but enabling your team to be able to test, to be able to create better security practices.
Sure.
Now,
and I really like the example of how you made sure that it could only be applied to the workloads OU.
Exactly.
Now, Bertie may have mentioned that you might have a session at Reinforce coming up, talking about this very topic.
There is actually a session, so if you're going to be at Reinforce, please join us as GRC 352. I don't remember the exact title, but that's the ID, GRC 352.
Awesome.
And we will dive more into this. So
Great. You guys, thank you so much for showing us this. I learned a lot, and I think this is very powerful to help enable agility and development teams to do cool things while still keeping security in control of what they need to do. So thank you very much. Stay tuned. We're going to be back in a moment with more awesome content here at Day 2 at the Washington, D.C. Summit here in Washington, D.C., appropriately named Summit.
Thank you.
segment of AWS On Air. We are live in Washington, D.C. at the 2023 AWS DC Summit. My name is Jeff Marushak. I am a senior solutions architect on our DoD Air Force team. And joining me, we have a bunch of guests, but my co-host Kyle.
We found Nick's power button. I'm Kyle Dickinson, your neighborhood-friendly senior security solution architect with a focus on threat detection and incident response. ASL interpreter, legendary over there.
Woo!
Keeping up with the insanity.
Normally, we see the ASL interpreters kind of like in the window, but I actually see them right there, which is awesome. So they're on set, part of the crew. Thank you very much for your efforts. Okay, so we're going to be talking about EKS, EMR, observability, Prometheus, Grafana, but let's introduce our guests here. So we have Vikram and Amaya. Go ahead, introduce yourselves and tell us what we're going to talk about.
All right, thank you. So hello everyone, my name is Imaya. I'm a principal specialist solution architect and I focus on observability. Glad to be here.
Awesome.
Vikram?
Hey folks, thanks for having us. My name is Vikram Vengatraman. I'm a principal container specialist based out of the DC area. And I focus on containers and observability.
Okay, cool. So let's start with, I did a lot of
acronyms
to start things off. Let's start with EMR. What is EMR? And we'll start there. And we're going to build off of this question.
Sure. Amazon EMR is actually a service that provides managed compute environments to run big data frameworks such as Apache Hadoop and Apache Spark. Customers use a variety of programming languages such as Java, Python, R, and even purpose-built programming languages such as Apache Pig to run their jobs, big data workloads, generally to process vast amounts of data for data processing, data analytics, and business intelligence workloads.
So how would a customer normally run EMR? What are their options? Let's say before what we're about to talk about today.
Right, yeah. So today we're going to talk about EMR on EKS.
Yeah.
However, Amazon EMR has been a service that always allowed customers to run such workloads, such big jobs, to process vast amounts of data on EC2.
Yeah.
EMR and EC2 has always existed, and customers used that to provision infrastructure and run their jobs on EC2 environments.
Gotcha. So now with EKS, which is the Elastic Kubernetes service,
yes.
This is implying that now customers are able to run EMR in containers in a Kubernetes environment. Let's talk about that a little bit.
Yeah, Amazon EMR on EKS allows customers to run workloads that they would typically run on EC2, but in Kubernetes fashion, in Kubernetes clusters.
Sure.
That makes them have better resource utilization. They can share a common pool of resources that their application workloads are running, and with that, they're able to have better collaboration with application teams. They're able to use the already established best practices that the application teams have done in terms of security, observability, et cetera, on EKS environments. And that is exactly where the topic that we're talking about comes into play as well, which is monitoring EMR and EKS workloads using something like open source software like Prometheus.
Now, are we talking about on Fargate or EKS on EC2?
EKS on EC2.
Okay.
Yeah. And well, like I said, this allows customers to standardize their security and observability posture. Yeah. And EMR customers don't have to wait for infrastructure to be provisioned. They can just use an existing EKS cluster that's already available that they're using for their application workloads. So their wait time is a lot less, and also they're making use of the resources very effectively, which reduces costs and gets done things faster.
But monitoring strategies are a little bit different for containerized workloads.
Yep.
So let's talk about what that looks like. What are some of the options customers have for this observability?
Right. So EKS in particular, Kubernetes customers really like using Prometheus. Prometheus works in pull model. What that means is you don't have an application that is pushing its performance and health information to a system, whereas Prometheus goes and scrapes data from workloads. So what that means is Prometheus needs to know where to go scrape, and Prometheus works really well in Kubernetes environments because it uses Kubernetes Service Discovery APIs to discover targets, to go scrape the targets.
And I think that's important that you mentioned that it's not actually installing something within the container, causing bloat to the container itself, because one of the benefits is having those as agile as possible
Yes.
or microserviced as possible.
Yes, you're separating the concerns there,
Yeah.
and which is the best thing, which is the right thing to do, because you don't want a container to be doing too many things that it's not supposed to do. Your jobs are just focused on doing their actual activities and processing the data, where you have your Prometheus cluster, or Prometheus server, or an OpenTelemetry collector that can go scrape the targets and get the metrics from the targets.
Awesome. Now, I see we have a screen up. You're going to be showing us some awesome stuff with observability on EMR, on EKS. Do I have that correct?
Yes, that's right. So what we're going to show is we're going to show how customers can use a Prometheus server to scrape metrics from their EMR on EKS workloads. And but the thing is, like, you scrape the metrics and then do what, right? So you have to keep the metrics somewhere. You have to have the ability for you to query those metrics and visualize and alert and all of that stuff. That's where managed Prometheus service comes into play. So with managed Prometheus service, customers are able to collect really large, amount of Prometheus metrics and store them for the for long-term storage, and query and alert and visualize and do long-term analysis of their performance of the jobs over a period of time very easily without having to provision any infrastructure.
Yeah, then I imagine you'd probably want to take it a step further and do a dashboard
Yes.
of those findings.
Yes, querying is one, then visually experiencing the whole data as to like how the performance was over a period of time. That's another thing that we're going to show. How to deploy the Prometheus server, send that to managed Prometheus service, and also use Amazon Managed Grafana, which is another fully managed Grafana environment, to query that metrics and show and visualize.
Yeah, that's exciting.
Those metrics as well.
I used Managed Grafana in a builder session yesterday, talking to IoT Sitewise, so really excited to see Grafana in another use case. So yeah, let's go ahead and see what's going on.
All right.
Thank you, folks. So what we have here is an Amazon EKS cluster where the Spark jobs are going to run. Now, EMR and EKS virtual cluster uses a namespace. So all your Spark jobs are tied to a specific namespace, and that's where our jobs will be running. So this is the cluster I have here. As you can see, I have some bunch of pods running. And what I would like you folks to focus is the Prometheus namespace, where we have the Prometheus server running. So this Prometheus server has been configured to scrape the metrics and store these metrics into Amazon Managed Prometheus Workspace. So let me quickly show you the config there. As you can see here, we are writing the metrics to Amazon Managed Service for Prometheus. We'll have to keep in mind that these Spark jobs are short-lived, so it becomes really important to scrape the metrics when they are available and reliably store them, right? So we have the Prometheus server configured here, and then the next thing we can do is how are we going to expose these metrics, right, from the Spark jobs? So for that, we'll be leveraging a Prometheus servlet config that's available with Apache Spark 3.0. So which means that you don't have to instrument your applications. You just have to enable that library, and that will in turn start emitting the metrics which can be scraped by Prometheus server.
And so by instrumenting, you mean you don't have to create like some sort of custom output to be able to provide visibility into this. It's just there.
Exactly. Yeah, so it's like a new feature of Apache Spark to directly connect into Prometheus.
That's correct.
Gotcha.
Yep.
Okay.
It doesn't necessarily connect, but it exposes metrics in the Prometheus format.
Okay.
Perfect. All right.
So, and that's the servlet config you see right there. So we have the collector configured correctly to store metrics. Now we have the application ready to emit the metrics. Let's go ahead and submit some Spark jobs.
So this is going to spin up some new pods to do something, and you're specifying what regions it's in, the EMR, the cluster.
The cluster ID is something that is mapped to a namespace within the EKS cluster.
Okay.
So that's exactly where your Spark pods will be running.
Gotcha.
So, and then we'll assign necessary permissions so that EMR and EKS can submit pods in EKS cluster. And definitely we would want to collect the logs. So we specify a log group for that. And this is just to copy some files for the Spark jobs. And there we go. the job is running. So in EMR and EKS, it's really important to collect the metrics of both executor as well as the driver. So the driver is responsible for initiating the execution, the Spark jobs. So it's equally important to collect metrics from both these components, right? So you will see in a moment the pod will show up in a specific namespace, which is the EMR-data-team-A. That's going to be the namespace where we'll see the information. As it goes, I'll quickly go through the Grafana dashboard. So what we have done here in Grafana is that we've made the Grafana workspace connect to an Amazon Managed Prometheus workspace. So the workspace that you saw in the Prometheus config is what it's connecting to. And we've also built a custom dashboard to synthesize the metrics that we've collected, namely the executor and the driver's metrics. As you can see here, I have a dashboard here for Spark jobs, and it collects a bunch of metrics. As you can see, the pod states, the metric ingestion, the driver CPU memory usage. Let me increase the duration so that we can see some data here. As you can see here, we'll start to see more data populating here since the job is running in the backend. But we have the driver CPU usage, executor CPU memory usage, and more importantly, you also have the heap memory usage, the JVM's heap memory usage. So you don't just create a dashboard and, okay, yeah, you have good visibility on the application, but you would want to have some actions built on top of it. Like, for instance, if your heap exceeds the threshold, then you would want to send alerts to your operations team. So you can further extend this dashboard to integrate with solutions like Slack or PagerDuty so that your operations teams can get paged and they can get take necessary actions.
Is there default connections between Grafana and the managed Prometheus service? Because when I created my dashboard the other day, you go create a new data source and then you search for my case, it was IoT SiteWise. Do you search for Prometheus or what are you? How are you building that?
Yeah, so with managed Grafana service, we have out-of-the-box dashboards.
Perfect.
Out-of-the-box data sources for managed Prometheus service that automatically detects your workspaces in that account, and it's just single click, and it uses the IAM role that you already assigned for the Grafana workspace.
Perfect. Yep. Yeah. Awesome.
So this is the data source, actually, the one Nimaya was talking about. We automatically added that. Cool. And also on the console, you could now see the jobs are starting to show up. We see the driver pod coming up, and in a moment, you'll be also seeing the Spark jobs, the actual jobs running on the EKS clusters. There you see the jobs are already starting to run, and we should see the data here, the utilization data here shortly. There you go. You're starting to see the driver CPU usage. The executor CPU usage is starting to show up. And you also will see the heap memory usage. As you can see, currently we are utilizing a little over 200 MB for these Spark jobs, executor jobs.
That is pretty impressive. And with these out-of-box connectors, the development teams, they could focus on what they want to do and develop, not try to figure out, through in depth how to just get visibility of metrics as to their workload that they have.
Yep. Yeah, they don't. They just can focus on their jobs, writing the jobs and spinning them up. No infrastructure provisioned for to run their jobs on EMR and EKS. No infrastructure provisioned to have a Prometheus environment. No infrastructure needs to be provisioned for Grafana either. So they get everything easily provisioned, accessible. All the dashboards and all of that stuff.
Now, do you have any workshops or references that, those that want to get started using this can reach out to and take a look at?
So we do have the observability workshop. It's called One Observability Workshop. You can go to observability.workshop.aws. We have, it basically goes through all the observability features that AWS has, including CloudWatch, X-Ray, Prometheus, Grafana, OpenTelemetry, everything. It doesn't necessarily cover EMR and EKS specifically, but going through that will still give you lots of insights into how you can monitor Kubernetes environments and all of that. So the concepts are the same, essentially.
Yeah, well, Amaya Vikram, thank you very much for joining us today. This was really cool stuff.
All right.
I always love seeing Grafana and seeing, like, Grafana always kind of wraps up like a solution or a project, so it's really cool to see.
I like dashboards.
Yeah. So everyone, thanks for tuning in. We'll be right back after this message with our next segment.